Bottom navigation bars are great for apps that have a limited width running on mobile devices. But use a bottom navigation bar on a larger screen that's running on web or desktop, and each nav item takes up more space than it needs, and, well, it just looks off. Instead of forcing a bottom navigation bar where it doesn't belong, check out Navigation Rail. Navigation Rail is a side navigation menu with the same functionality as bottom navigation bar. It gives users quick access to navigation destinations, only designed to work better on large screens. To get the navigation rail up and running, give it a list of navigation rail destinations, a selected index, and an on-destination selected callback, which gets called each time a nav item is selected. From there, add the navigation rail to your page, maybe in a row alongside the main content area of your app, and you're good to go. To get a little bit fancier, you can also set a minimum width for the navigation rail, enable and style the labels for the navigation items, configure the navigation rail's elevation, and add a rounded highlight behind the currently selected icon. Switch things up by giving the navigation rail a background color or modifying the rounded highlight color using indicator color. You can also add leading and trailing widgets that will show up before and after the list of destinations. A common trick is to use the media query to determine the overall size of your screen, and use a bottom navigation bar if its width is below a threshold of your choosing, and a navigation rail if it's above. One of the time-honored Flutter traditions is running Flutter Create, deleting everything, and then laboriously copying and pasting in all of your standard boilerplate. This takes forever, is highly error-prone, and is less fun than paying your taxes. Does it have to be this way? Enter Mason, a package that's all about quickly assembling new projects, or features, out of predefined building blocks called bricks. Mason works by containing entire directories of mustache templates that it renders against values specific to your project. For example, imagine the pubspec.yaml file in a Mason brick you're using for a new Flutter project all about comfortable socks. With that brick, it might look like this. If you're using Firebase, it will produce a pubspec.yaml file that includes the Firebase dependencies. And if you're not using Firebase, then those dependencies get skipped. But how does Mason know your project's name, or whether you're using Firebase? Enter Mason CLI, which is sort of like Flutter Create, but more flexible because it uses Mason and custom bricks. After installing it, you can run Mason make with the name of a brick, and Mason will read the brick's manifest file and ask you some questions. In this case, it'll want to know your project's name and whether you're using Firebase. Mason CLI supports a variety of data types, including strings, booleans, numbers, and enums. This leaves just one question. How do we find the names of the bricks we want to use? For that, head over to brickhub.dev and check out the publicly available bricks. Flutter developers all over the world are already uploading their opinionated boilerplate to help you save time. If you don't find one to your liking, convert your own preferred Flutter project structure into a brick and upload it, to save yourself time in the future, if nothing else. And by the way, bricks can be any size, not just entire projects. Find yourself creating the same few starter files every time you begin a new feature? Well, that's a great candidate for a brick too. With Mason, you can get on with writing the interesting parts of your app more quickly than ever before.
Material buttons are great, but we know they're not always right for your app, so you write your own. Sadly, writing your own controls from scratch can be a lot of work. Desktop users expect hover highlights, focus, and keyboard shortcuts, which is tricky to get right. It goes something like this. You create a custom button in your app. Thanks to Gesture Detector, the button does things when you click it. You add in the appropriate variables and functions to store and manipulate states such as on hover and on focused, throw in some conditional styling for the button, give the button a mouse region, wrap in a focus widget, then an actions widget, and finally a shortcuts widget. Not to mention, nesting order matters for 3 of the 4 widgets, so if you accidentally put focus on top, nothing works. So tedious. Oh my, build method. Okay, so your build method has become a bit unwieldy. It's now at least 4 widgets deep, not including the gesture detector. So before you write all this boilerplate, check out Focusable Action Detector, which combines all the functionalities from actions, shortcuts, focus, and mouse region into a single widget. Instead of nesting all 4 widgets, replace it entirely with Focusable Action Detector. Give the Focusable Action Detector the same information that you passed to the previous widgets: the map of shortcuts, map of actions, a callback for focus changes, and finally a callback for hover changes. There you have it, a focusable button with hover effects and keyboard shortcuts. All the functionality you want without having to make sure that you're manually nesting 4 different widgets together in the right order. You've added an amazing new dark theme to your Flutter app, and because you love your users, there's even a toggle to enable and disable it. Everything's great until you realize each time you launch the app, it reverts to the light theme. That dark theme preference isn't being saved anywhere, so it doesn't persist. Right. You could save this to your server as a part of your users' accounts, but that feels like overkill for a simple Boolean flag. Or you could save it to persistent storage on the user's device, but this is Flutter, so your app ships to different devices with wildly different APIs for local storage. Enter the Shared Preferences package. Shared Preferences is a plugin that abstracts away the platform-specific persistent storage methods across Flutter's supported platforms. This means that you can use the same code to access persistent storage regardless of device. Shared preferences on Android, NS user defaults on iOS, local storage on web, the app data directory on Windows, you get the idea. Whatever the platform, Shared Preferences has you covered. It's great for saving simple data like, well, the user's theme preference. Once you've added Shared Preferences as a dependency to your app, create the Shared Preferences instance and start saving your data. Int, double, bool, string, and list of strings are all supported data types. Whenever you need the value back, look it up by its key. If the data doesn't exist, you'll get back null. And when it comes time to test your code, Shared Preferences contains its own mocks. This enables you to set initial values for testing without using any platform APIs that may be unavailable during unit tests. One thing to remember with Shared Preferences and persistent storage, there is no guarantee that the writes will be persisted to disk. So make sure you don't use it to store any critical app data. Ever looked at your app and thought, the default system font looks fine, but I really wish I could make it more distinctive? In that case, try out the Google Fonts package. Google Fonts lets you access over 1,400 font families without storing any font files locally, making it a great option for faster development. If you already have a text widget, just give it a Google Fonts text style. Already styled your text and just want to change the font family? Wrap the existing style in a Google font. Instead of changing the text style on every single text widget in your app, save yourself some time by using Google Fonts to make a text theme instead. By default, Google Fonts will try to fetch the fonts over HTTP. Note that on macOS, you have to make sure that network fetching is allowed by including these lines in the app's entitlements files. Picked out the perfect font for your app? You can bundle its font files into the app assets. Once you do that, Google Fonts will automatically use the matching font files in your pubspec.yaml instead of fetching them over HTTP. Once you've bundled the font files as part of your app assets, you can disable the HTTP font requests altogether by setting the allow runtime fetching config to false in the app's main method.
Imagine you're a painter redoing part of a home, but every time you try to paint just one wall, you accidentally get a few drops on an adjacent wall, and before you know it, you have to repaint the whole room. This is similar to how Flutter's rendering works, with each room in our hypothetical house being a layer in Flutter's layer tree. Anytime Flutter needs to repaint something in a given layer, it winds up repainting the entire layer. Painters get around this by adding blue tape to edges to keep their paint off adjacent surfaces. So, wouldn't it be nice if Flutter developers had a similar trick? Luckily, we do. It's called Repaint Boundary. To start, set debug repaint rainbow enabled to true in your main method, right above where you call run app. This flag tells Flutter to draw a colorful border around each repaint area and to change that color whenever the area is repainted. Now launch your app and look for which border colors change. If you have an animating widget, of course its region will change colors. But if unrelated regions or your entire app are also changing colors, then the little painter inside your Flutter app is probably repainting entire rooms. To fix this, take that animating widget and wrap it in a repaint boundary. Repaint Boundary works by separating its child widget into its own layer, which makes it impossible to accidentally splash paint on neighboring widgets. Now run your app again and notice that even though your animating widget keeps on animating, its neighbors no longer continuously repaint themselves. But keep in mind, it's good to check for these unnecessary repaints before wrapping everything in a repaint boundary, because repaint boundaries do have a small CPU and memory cost that can add up. For more info on Flutter and all the other widgets,